Hello everyone, just going to do a quick run through of the latest DAC qualifying round with this lovely case from Julian about Lake Constance. This was the first time I managed a full solve in a live round, so I was very pleased. Probably to do with Julian's generosity in, not providing lots of reading material, which made it a lot more straightforward. I also watched his intro video, and as per the advice always given, I planned my strategy carefully, and I made an early decision to flatten all the data, which I think meant I was a bit slower than some other people, but also didn't make any mistakes. So that's what I'm going to do here as well. Okay, let me just import my lambdas, and then let's go. Okay, so I'm just going to flatten all the data to begin with, because that's what I did yesterday. So I'm going to unpivot this table of inflows. I have to select the values, I have to select the key columns, which are the dates in this instance, and the labels for the data. And that is down here, dates, river, flow. And I'm going to copy and paste values there and put that one into a table, which we will use for one of the questions, I think. Did I actually name that? Yes. So that's going to call that TR. And I'm also going to put a litres column in here so that I don't have to work it out later. So multiply by the number of seconds in a day and then times by 1,000 to get to litres. Okay, then I want to get to the, I'm going to create a copy of this data, because I'm going to create a second flattened table where I put in all the other inflows and outflows. So here we've got the rain, which is another inflow. So put the dates there, put rain in here, and I just need to get the values. And lastly, we need the outflows. So I'm going to do another unpivot on this data, select values, select the key columns, select the headers for my values. Okay, and actually in my unpivot, I'm going to multiply by -1 immediately. So those are now outflows as opposed to inflows. And I'm going to paste that values to the bottom of my table. Let's get rid of this litres column for now. So that should be everything. Turn that one into a table, which I'm just going to call T. And then I'm going to re-add my litres field here. Sorry, I'm a bit zoomed out, but that's the nature of it. Multiply by number of seconds in a day, multiply by 1,000. Okay. So that should be all the data I need for the first few questions. So I think in the first one we can just use the total table. So I'm going to do a sum ifs of T litres, where T river is equal to this one, Alpenrhein, and T dates is equal to this guy. I don't think we actually need to bother rounding, so I'm not going to. Hooray. Second level, we just have to vary the river. So we'll place that with, reference to here. Paste down. Lovely. Net water flows of all inflows and outflows at the corresponding date. So that is litres of T dates equals this one, should be. And we might need to round. Not sure, let's check. Okay, perfect. Level 4, we have to work out how the water level changes compared to the beginning of the year. So we need all inflows and outflows before and on this date. and then we need to adjust it for the number of lake cells on the map, which we haven't looked at yet. So here's the map. Select the map, and I'll call it map. And I have a UDF, some VBA, where I can translate the map properties based on a legend, which is really slow to select in this sheet for some reason. Okay, there we go. And I'm just going to make this a bit easy for me later by changing that to C and changing lake to L. Okay, and there's my map. It's a bit slow, so I always copy and paste values. So it's now a static map, and I'll call it map C. Okay, so we want to know the number of lake cells that there are. So I'm just going to calculate that up here. So that's going to be a count ifs map C is equal to L, 552. And now the way I did this is I added everything up and then just adjusted everything until it was the same as the example answer, basically. Vibed it. I've only just started to trust some ifs when creating essentially a string condition, which always feels weird. Like, is this going to work less than or equal to a date where it's a string? But it does work. Okay, so divide that by 552. That's like, yeah, it looks the same. Kind of looks like we need to divide by 1,000,000. So let's do that. Let's round. And hopefully that will be right. Hooray. Okay, and now we're sort of done with the water stuff and we're on to map stuff. So this is saying what country is the corresponding city in, so we have to look for any adjacent cells. There are no ambiguous cases. So what I did here is I looked up, using my grid lookup, from the map, this guy, which tells me where it is. Then we want an area around that to find the adjacent cells on my translated map, and I have to put the original map as the origin to make sure we're in the right place. And then I can do now I don't know which of these is going to be a country. So I then did an X lookup on the 3 countries, returning from the 3 countries, so that I'd get NA for any that weren't a country. And then just did a @2col, filter out the errors. Okay. Level 5. Level 6 is what is the direct linear distance between both cities? So that is just cell distance. It's very lambda heavy, this solve, of grid lookup on map this guy to grid lookup on map this guy with 2, which is Pythagorean distance. And then we probably have to round, don't we? Yes. Okay. And lastly, well, this is like you either have a maze lambda or you don't have a maze lambda, which is an adaptation of Hayden's one. Shout out to Hayden. So it's a maze of the start is the grid lookup from my map of this first city. And then our allow map is, this is where we're allowed to go. So we're only allowed to travel on the lake, but we also need to include the cities because that's where we're going to. So if I just do map C equals lake plus map C equals city, that will take care of that. Technically, I don't need an origin because the original map is located in cell A1, which means the maps created by my dynamic arrays will be in the right place, but I'll put one in anyway. And then we need to add a target. So the target is where we're going to, which is grid lookup on map of the second city. Now that's slightly wrong because we have to, when we're moving diagonally, we want to use Pythagorean distance, which is the square root of 2. Luckily, I have a lambda which makes adjustments like that, maze lambda diag. Unfortunately, for some reason, probably because of the case it was based on, that lambda translates a diagonal distance to 1.5 rather than the square root of 2. So that means I need to go and adjust it. So I go down to the maze lamb diag lambda and change 1.5 to square root of 2. Done. And if I now round that, should give me the right answer. Copy down. Hooray. Bonuses. Which river is providing the largest total inflow? So that's where I needed my T river table the only time, and I want to do this as a most of, right? So most of my values are TR river and my weights are TR flow or litres, doesn't matter. What's the total inflow use only rivers in litres on the day with the highest inflow? So I need that again. So I basically need the max of, I'm going to do a map for each, do I need a map or can I just do some ifs over an array? Probably, let's try it. Some ifs of TR total inflow, I need it in litres, TR litres where TR dates equals unique TR dates. Amazing. On what day is the water level the lowest? So I'm not sure this will work with a pure array formula. So I want to do what day is the water level the lowest? So I want to do a min of, and my values are going to be, if I map across unique unique dates, and for each date I want to do a sum ifs of T, doesn't matter if it's flow or litres, sum ifs T flow where T dates are less than or equal to, and D, close the sum ifs, close the lambda, close the map. That should be my values, and now I need my labels, which are my unique T dates. Nice, 24th October. How many cities on the map are in Switzerland? Now this one's actually quite complicated because you need to find out, only joking, we just count them. 1, 2, 3, 4, 5, 6, 7, 8. Based on level 6 rules, what is the largest distance between two cities, round full kilometres? Okay, can I do this in one cell? Why not? So all the cities are, I need to filter to call the addresses of my map C, hold on, where my to call of map C equals C. So that gives me all the addresses. And then I want to know the largest distance between two cities. So I want to max of a, no, hold on. They can be my adds. And I want to do combinations of my adds of two of these. And I want to do a by row of those. And for each row, I want to work out the distance between the two things. So I'm going to do a pair op. It's getting silly now. Where I do a lambda AB, which just takes each item, in the row and do cell distance between A and B. 2, close lambda, close the pair up, close the lambda, close the birow. I've completely lost track of where I am now. Close the let. Oh, and I want to do a max, don't I? And then I want to round that. Yeah, let's just do it around the entire thing. Okay, done. Thanks for watching. That was quite fun. See you next time.